So what we want to look at is this idea of what's responsible for holding an object in a circular path. So when we have our object, so let's say we have a ball attached to some string, and the ball is moving with some speed v around our circular orbit. And when you're thinking about this, in order for the ball to continue moving around in its orbit, there must be something pulling the ball in, some type of force. And so there must be some force pulling the ball inward, holding it in this path, in this circular path, because if there wasn't something holding it in place, the ball, according to Newton's first law, would continue moving this way. It would continue moving straight. So there must be something that's pulling the ball into this circular orbit, allowing it to maintain this circular motion. And what happens is any force that causes something to maintain a circular orbit is called a centripetal. It's called a centripetal force, which is just any force that causes an object to maintain a circular motion. And so the centripetal force is just a label given to any force that does that. So you could imagine that I'm like holding some string, some ball on a string above my head, and I'm like swinging it around, and the ball is moving in a circular orbit. So what's going on is the tension in the string is supplying the centripetal force that holds the ball in the orbit. Or you can think about the fact that the Earth moves around the sun. Well, the sun's gravity supplies the force that holds the Earth in that circular motion. So this centripetal force, and this centripetal, this means center seeking, is essentially just any force that causes your object to move in a circular fashion. Another example of this type of force, another centripetal force you can think about is, other than a ball on a string or maybe a planet, something that's closer to you. Whenever your car makes a turn, so if you're in your car and you're driving around a turn, what happens? This is some type of circular motion when you round a curve because you're on a curved path. It's like a circular motion. There has to be a centripetal force, some type of force pulling you towards that center of the circle. If that force isn't there, what happens? Your car skids out. So there must be some type of force that holds you in when your car turns a corner. Now, what supplies this force? In the case of a turning car, when your cars turn, the friction between your tires and the road holds you in place. So this is a time where friction is actually useful, and it doesn't do bad things for you, like in lab a lot of times. But the idea is that friction holds your tires in. The force of friction between the tires and the road holds your car in on a turn. So when we have this centripetal force, if we want to quantify it or understand how that force works, the idea is that the centripetal force, which of course we said is supplied by something else, is supplied by different forces. The result of the force that's supplied by something else is mv squared over r. So if your force, let's say we're looking at our turn, if the force of friction isn't larger or isn't doesn't match mv squared over r, what happens is your car skids out. So that's why you can only take turns so fast, right? Because if your v squared is too large and your friction of the force of friction of your tires isn't equal to this, your car skids out. And this is the idea. So you can see that as v gets larger, your force, what's supplying that force, has to get larger as well. And then r, as you make r larger, the force that's needed to hold the orbit isn't as large. So this is kind of the idea. The centripetal force is supplied by something else, like friction for your car, gravity for a planetary orbit. When I twirl a can above my head, the string supplies, the tension in the string supplies the force. And here's the next example. If I was twirling that can too fast, then V would get large. If this force required is larger than the string can snap and the object would fly away. So this is the idea of the centripetal force. It's a center-seeking force that pulls the object in and holds it in its orbit. And it's always supplied by something else. It's just the centripetal force is the label given to a force that holds you in a circular path. Now, we don't want to get, now what we want to think about leading off of centripetal force, there is actually a force that people get confused with the centripetal force, and it's called the centrifugal. Now, what the centrifugal force is if you imagine, let's now go back to our, can above. We're swinging we have our ball, and it's on a string, and we're swinging. Now, or let's pretend that it's a can. We're in some kind of can, and we're attached to a string, and the can's going around. Now, if you're inside this can as it's going around, so let's say now that you're standing here on the can, and the can is moving this way, what you feel standing in the can is a force pinning you to the bottom. And you feel an outward, so the centrifugal force is an outward force, or a center fleeing force, but this force is only felt, only experienced, we'll say, only experienced in the rotating frame. So the idea is this centrifugal force, you only experience it if you're sitting here inside the can moving, then you feel a force pinning you to the bottom of the can. But what really is happening, if you were the outside person watching this thing happen, what you really see is that you say, no, there's not some outward force pinning you to the bottom. What's really happening is the bottom of the floor is pushing you in, and you're really experiencing the centripetal force from the bottom of the can pinning you in. There's really not this centrifugal force pinning you down, but in your rotating frame, you feel it as you're being pushed to the bottom of the can. And that force in the rotating frame is called the centrifugal or center fleeing or outward force. But it only exists in this rotating frame. Otherwise, if you're standing outside and you're the one twirling the can, this force doesn't exist. When you look at it, you know that it's really supplied by the, because the can is experiencing a centripetal force inward. So it's this force that arises in the rotating reference frame because we've already said that Newton's laws act here differently in in accelerating frames, and that's essentially when you're inside the can, you're in one of these accelerating frames. So that's where that centrifugal force arises from.